Friends, today we will demonstrate FSK modulation and demodulation. FSK stands for frequency shift keying. So for any modulator we require modulating signal. Here modulating signal is the what data signal. So this is your data generator in the form of parallel to serial converter. So at the here is a clock input. So at clock input we are feeding the what clock. So clock actually defines the what how fast your data is changing. It can also thought as a but a bit, it defines bit rate. Then this data pattern we have selected about 10 10 10 10. You can change accordingly, right? You can change accordingly, but we have chosen this. So this data is uncoded data, digital data, uncoded digital data is fed to the what line coding. Line coding we have chooses NRZL. So this here we will get NRZL data that we will actually take as a input to the our modulator, FSK modulator. So here we actually FSK modulator is actually achieved or realized through two modulators. For two modulators, for one modulator we will give in the direct generated data without any modification, and the second modulator we give in the inverted form of this data. See, this is the inverter. So say the same data which is giving directly to the modulator 1, the inverted form of this data, this is the inverted form of this original data is giving to the modulator 2, and modulator 1 we are giving one high frequency signal 1.6 megahertz. See, this is 1.6 megahertz, and modulator 2 we will giving what low frequency signal, that is 960 kilohertz signal. So how this modulator actually works to produce FSK when the data is actually high. Suppose the input data is high, then the this modulator 1 passes the high frequency to the output, and where modulating signal or data signal is 0, then 0 means your inverted output is high, and your low frequency signal passes through the modulator 2 from modulator to the output, and these two frequencies alternatively pass through the what output, means one time one frequency, another time another frequency according to your data, and these two frequencies are added in what through the summing amplifier and produces the FSK output. Now see this FSK output. What you are seeing, what data we have chosen, 10 10 10. So data is what matching that right, matching as per your generated pattern. And see that this is FSK modulated waveform. See, when the data is low, the frequency is low. When the data is high, the frequency is what high. Again, data is low, frequency is low, and when the data is high, the frequency is high. So this is the demonstration of your FSK waveform. Students, now we will do the demodulation of FSK waveform. So here is the FSK output is generated, which is given to the input of FSK demodulator. So FSK demodulator you can use Foster Seeley or ratio detector, or any type of FSK demodulator you can use. Then here FSK demodulator output is given to the input of low pass filter. Any demodulation process requires a low pass filter, because your modulating signal which is required to be extracted or which is required to be detected is a low pass signal, right? Then your low pass filter output is given to the what input of the comparator. Here two comparators are there, but you can use any of the comparator. So comparator actually work as a threshold detector. If your output is above threshold, it is generated output as 1, otherwise it is your output is less than threshold, it is generated output as what 0. So see this at channel number 2, this is violet color, it is a what your demodulated output, and yellow colored is your original data signal. So now we can match that demodulated output is matching with the what your original data signal. Original data signal is 10 10 10 10, and your data is also 10 10 10. There is certain delay, because delay comes due to the what transmission between transmitter and receiver. Here we are using two kits separately, one for modulator and another for demodulator. So we have made connection through some cables, and there is certain delay. That delay is observed here in the what output. Right, now see this, because we have taken data 10 10 10, but we can change the data and see the what demodulation process is working properly or not. So I am changing the data. Now the present data is 10 10 10 10. Now we are taking the data is what 111. So now see the whether we see the what difference. So see this, now the data is what certain delay periodic pattern is there, 1110, then 1010, right? So again the data is what your demodulated data is following the input, right? See this 1110 1010. So this is your demonstration of FSK demodulation process.